That is the data and information. So collection of the data is the database. So our goal is to build a database. However, how can you build a database? We need something software, because computer can run only the application program. To manage such a data, we need something application program software. That is called database management system. For example, Oracle, Informatics, DB2, SQL Server, Sybase, and so on, MySQL. Those are nothing but software running on operating system, computer. It's not the database yet. Database we model for university. Then to implement such a database, we need software here in the computer. That is DBMS. So if you are just looking for running DBMS, Oracle Informatics, it's a waste of time here. So you can just visit the website or the purchasing book or manual for Oracle Informatics only, then you can learn that software only. But in this class, before that, we will learn the concept of database. Database modeling, data modeling, and design part. Okay? Then, so we'll discuss about the benefit or the characteristic of using database approach, right? So database is what? Self-describing nature, which means we don't have to know everything about the data structure. DBMS system no maintain such a, for example, in here we have the simple database for university. So student consists of name, student number, class, and major. If you are not using the DBMS database system, in other words, just a file. This, think about regarding this is a file, text file. So it has the name, student number, class, major. To access the data in the file, in your program, for example, C program, how can you access the data in your file? Open the file, fopen, or similar. Then read the data byte by byte, then close the file. That's it. In case the name is 8 byte, but there's a new student with long name, so we need a 10 byte. When you change the data, your application program should be changing and recompile, then run it again. Okay? However, if you are using the database approach, you don't have to do that. Why? Database is set, manage all the information. If you want to change the name 8 byte to 10 byte, it will be managed, handled in the database. In your program, as an application program, you don't have to worry about it. That is the benefit. That is also called what? Program and data independent. Data separate. Also that is called abstraction. Abstraction means, what is the abstraction? Have you ever take the object-oriented programming course, CS400? You probably
we are taking it now. We are taking it right now.
Actually, you'd better take the before this class. Okay? Anyway, it doesn't matter. What is the object? Do you know? Should you know everything inside the object when you are using object? No, you don't have to do that. Okay? Instead, what you guys need to know is name of object and method. That's it. You don't have to worry about what's going on inside. That is the benefit of the object. That is called abstraction. It hides inside. If you should know everything, wow, it will be very, very complicated. It's the same in the database. Database, you don't have to worry about how to store the data inside, which it describes what is the format. DBMS software will take care of everything. The only thing you need to care when you create a database is what? Database structure itself. The student has name and blah blah. Something like that. That is called abstraction. Those are the benefits of using database. So, the main thing when you are using the database is what? When you have very large data. Okay, I probably gave the one example, the company, small company who has 10 megabytes data. Do you need DBMS system even though the data is very, very mission critical? No. It's a waste of your time, waste of your effort, waste of the money. Instead, you can use simple program or just a file. Then it can be more secured and fast. Okay? So in case we have a very large data, we can get the benefit of the database. Okay? So in other words, if we have a very small size of data, also the cost, we need to think about the money. Even though we have the very important data, if it costs a lot, no, that's not a good choice. So considering the cost of money, so we need to think about the size of the data. So when not to use the DBMS, first, money and the size of the data. Sometimes using DBMS require overhead, also more effort, or more time to manage, and make it hard to make the program. Why it's difficult? So if you graduate, when you graduate and when you involve any project, at that time if you are asked by your boss or the manager, design the new system for customer management. At the time, you guys need to decide whether we need a database or not. If yes, what kind of database model? Relational database model or the hierarchical database model, some other database model. Then, do we consider the centralized single server or distributed server? And what size of database we need? That is the thing you can consider when you design your system. Okay? Then, before we start the main chapter, main activity, main topic of the database design, that is designing data to make information into the data. So we will discuss about the data model and database models. That will be discussed throughout the semester. First, what is the model? What is the data model? Have you ever used, probably you used a lot in computer science, right? So I did the modeling for my product or for my project, and we did the modeling. What is the modeling? When you are saying data modeling or the object modeling, what is the modeling? Characteristic of your data. Yes, it's getting close. It's a characteristic. Also, there might be common rules in the data. For example, I try to build a student database. So first you need to investigate or collect all the information about student. Then I realize each and every student has name and ID and GPA. Also somebody asks, I want a student address. Yes, address. And also male or female and age, those are important. And those are the common rules and common things in your data. So while you are collecting, decide and analyze such a data and such a rule, that is called the modeling, data modeling. Okay? In other words, if you can find the common rules or constraint. What is the constraint? Constraint means it's a condition of your data. Okay? So we discussed about the definition of the data. Data is organized, structured information. That means we need to find something common rules, common regulation, common constraint. How we can represent such a constraint? We can use structure, data structure, like the integer. Data structure is nothing new. You already know data structure. Like how can you represent a number? Number is, for example, integer. Integer is number of digits. So when you program it, main and this program, first you need to define the data value, right? Integer I and integer j. What does it mean? That is the data structure for your data. It's the same thing. First, when you design it, you need to find something common rules. It's not as simple as the integer I, but student, it has name, ID, address, and so on. Name is a 10 byte, and ID is 9-digit number. That is a common thing, rules or constraint in your database. So the processing to decide such a structure is called data modeling. One more thing is, I decide such a rule. So I create, for example, this kind of the university data. Okay, I model. Sometimes when you take a look at this student data and course data, there are some relationship. Okay, what kind of relationship can you find in this student and course? Student.
One to many.
I don't know anything about one to many.
Many to many.
I'm asking to the elementary student. Student is taking a course. Course has a
Many
student.
students.
Okay? Many students, sometimes one student. Okay? So there is a simple relationship between student and course. When you are when you are modeling, you can find such a relationship. Okay? So those not only for the exact things of the data, sometimes you can find the relationship between the things. That is actually basis of entity relationship model. In short, ER model. Have you ever heard about the ER modeling? There are a bunch of different modeling techniques. Probably you know the UML modeling. It's based on the object-oriented concept. And hierarchical modeling is based on hierarchical approach of the data. Hierarchy is very easy to understand for human being, right? From existence, parent, children, something. We can apply such a structure to the data. Okay? So that is called the actual entity. We will learn next semester, next week. The entity and relationship. That is one way to model. In addition to that, after you build such a data, what is the main objective of the modeling? Anyway, after we define the data and database, your application program need to access such a data. Like the C program, first you define integer I and integer j. Why do you define such a variable? You are going to use such a variable in your program. If you do not use such a data, you don't have to define it. It's a waste of space. So after define, after model the data, we should access such a data. That is called the operation. So each modeling has to show the way of accessing the data. From time to time, I use the building a house to explain the data modeling. So data modeling is kind of building a house. First, I try to build a house. Then what I need to do is design, outline my house with architect. Or I can be the architect, whatever. Then design, this is a room, this is a second story, two-story building, and after you build it, is that all? So is it for display? Is it for the art? No. I'm going to use that house. We need resident. The residents should know, I should know, my family should know how to access the house, built-in new house. Like if locked, I should know unlock, how to unlock the door. Then if I enter the entrance door, then which one is the living room, which one is the bedroom, which one is the kitchen. Each modeling should provide such a way to access the data. That is called the operation. So when you model the data or database, it should provide such an operation and as well as the constraint. That finding constraint, defining operation, but most of the database model provide their existing built-in operation, so you can focus on to find constraint when you model. For example, we decide the topic, project topic, as the cricket soccer game management system. In the soccer game management system, I need to model the soccer game management system database. At that time, you need to find which one is important information, like the player, team information, and salary. Then find the common thing. So when you list all the players, soccer player, you can realize everybody has the name. Everybody has the experience, how many of years, and team, where each player played, something like that. That is the constraint. And also, salary is the salary of all players are ranging from 10K to 1 million. If you realize that will be constraint when you model. So that is the step. Do you need any background in computer science? No. When you model, when you are doing the data modeling, you don't need any background in computer science. Everybody can do that. That's the reason right now you can start the data modeling without learning any database knowledge. You don't have to know about the table. You don't have to know about the Oracle. No. You don't need any such an. Instead, you'd better be expertise on that database topic. So that is the reason I asked you guys to discuss. After forming a team, your team member need to discuss which topic will be interest and handle. Taken care of yourself, taken care of by yourself throughout the semester. Not too difficult, not too easy stuff. Okay? There are two types of the data model. One is a conceptual model, another one is a physical model. Third one, if you read the textbook, Dr. Elmasri proposed one more model, but it's not common thing. It's his own opinion. Okay, so don't worry about too much third one. But conceptual modeling and physical modeling, probably when many of you guys want to get a job, right, after graduation. Me, I didn't know that when I started, but I believe many of you guys want to getting a job after graduation. At that time, you probably read a lot of job description. Some of the job description ask 5 years of the conceptual modeling experience, or said at least 3 years of physical modeling experience. If you do not know what is the physical modeling, what is the conceptual modeling, even though you have the experience, you cannot apply it. Okay? What is the difference? Conceptual modeling and physical data modeling. Conceptual modeling, in other words, high-level semantic modeling, is for conceptual level. High level, or semantic level. For example, you already know from bunch of information. So your customer provide this information for customer. We try to build a customer management system. Then from here, to build a customer management database, we need customer name, customer ID, customer birthday, customer's this kind of information. That is conceptual model. Do you need any knowledge on physical database? No. At that time, we don't need it. That is conceptual modeling. After we design, so output of conceptual modeling is, for example, this. Just this. Okay? This is not a database. This is a conceptual model. This is not the real database yet.
Yes.
Okay? We don't know how computer read. No. It's just sometimes the diagram, it can be figure, it can be table format. So it's not the real database yet. That is conceptual data modeling. Based on that conceptual modeling, our goal is to build what? Database. So to build a database, we need to use software like the Oracle Informix DB2. So that software DBMS system should have something model, common rule. That is called the database model. For example, relational database model. As he mentioned before, relation. What is a relation? We don't know yet. But some of the DBMS system consider data is relation. Okay, that is a rule. That is a common rule. So that is called a relational database management system. In short, RDBMS or RDB. So I have experience on RDB. That means it's a database model experience, physical level experience. Okay. Then based on the data, based on the conceptual data model, so we have a customer. We have the manager. Then how to create the database using database model? That will be physical data model. Physical database model requires some specification of each data, like the name, 8-byte character. It requires total 80 megabytes, something like that. Detailed storage or detailed model of the data. So that is the reason it's called the internal or low level, the data model. Okay. So we are going to learn both conceptual data model as well as the physical database model. So conceptual data model is the phase 2, second step of your project. Physical database model is the third step, phase 3 of your project. Then based on that, the final purpose, why did we build the house? We are going to use that house, right? In terms of the database system, we need application program that access the database. That is actually implementation, but it's not very critical. Anyway, that is last step, last page. So I think 1 or 2 students asked after last class, do I need to implement the program, application program to access the database? Yes, definitely. You should implement the program that access the database that you built in page 2 and page 3. Okay? At that time, you need knowledge on the program language. So you still have a time. If you feel I need more experience, more knowledge on the programming itself, you can. This is a good time to start learning the program. But if you do not have any knowledge or any experience on that, I don't think you have enough time to catch up everything in a couple of months. Okay? So yeah.
We can use C#, for example.
I'm going to explain details regarding to the program language. You can use any program language. However, regarding to the database management system, you should use Oracle database. I know I allow for using any DBMS system. Most students would like to select SQL Server because it's easy to connect and you don't have to do nothing. So I want for my student to be painful throughout the semester. I know it's not easy. First time user to set up the connection from your computer to the database, but after you finish it second time, it's a piece of cake. Also, every DBMS has the same mechanism, same structure, same model. It's a relational database model. So to catch up the other DBMS, it's not a big problem. So that is the reason I'm not a big fan of Oracle database. Sometimes I hate it because of the Oracle, the database research sometimes is bad. There's not much progress. 10 years ago, I used almost the same DBMS. After 10 years, the name is a little bit different. 10G or instead of 8i or 7, but it's still the same because Oracle is too big. And no matter, even though their function is terrible or the painful, but nobody argued. Just the customer followed their direction. But because of that, we'd better use the most popular used DBMS system. Okay? Also, for your test, you can install Oracle database on your laptop or on your system, but final product should work with the Oracle Addison-W, okay, which means remote connection. Some of the students just build everything on your local database, but final product should work with the remote database. Then, after you model such a data in database, that's called the database schemas. Database schema means, so we have the university database. University database has student and instructor, course, prerequisite, grade. Those things describe university databases. So such a model data are called as database schema. So your goal is to decide the university database schema or your own database schema. Okay? Then that can be represented by the diagram. For example, this one. So you can use we don't know how to do that, but this is our goal of database design, database data model. Output of such a data model is database schema. It has student, course, prerequisite section, and grade report. Because they are describing the database. These are the database schema. If you have the sample data for each, like the student Lee 111, class DPS 450, and major CS, those are called as instances. Because without the sample data, without the database should not be exist, right? So we need such a data, for example, this are called as instance. By integrating schema and instance is called the database state. So this database state should be available when you create your database system. Then from the application you can access the data. Okay? So this is your goal, to design and model the database. So database state has database schema as well as database instances. Instance means sample data. Schema means the description of your database. Okay? Then there are, as I said, there are many different types of the database model, like the relational database model. Relational database system based on the relation. What is a relation? It's not a relationship. A relation means a set. What is a set? Set is group of elements, like the natural number set or real number set. Okay? So we are going to regard each data as a set. That is a relational database model. We will learn in chapter 8 later. Okay, after we finish the data model. What else? Hierarchical model. As I said, for example, banking system is a good example. There is a headquarters bank, and under the headquarters there are branches. So branch 1, Bridgeport, Trumbull, Shelton, and Fairfield branches. Each branch has manager, banker, teller, and customer, and account. The other branch has the same thing. And each customer has their own account, something like that. This is a hierarchical approach. Based on that, we can build database. That is a hierarchical database model. Also, we can consider network. It's based on the network model. I never use it. I just learned from textbook, so I do not know much about it. So I don't want to explain to you. But it's not very popular. So I never seen real database based on the network system. Another popular one is object-oriented database model. We can consider each data as object. That makes sense, right? In your object-oriented program, you define, we can consider each variable as object, or the function as an object, each program as an object. So even the other program can access the object, your program, because they are object. However, why don't we adapt such an idea to database? Which means when we define the student data, student has so inherited by person, because student is a person, so we can use, the inheritance in object-oriented, right? Yes. So we can inherit. So we don't have to define again. Student is a person age and the sex and blah blah. No, if a person has, so we can adapt to such idea. But unfortunately, object-oriented model is not very popular. Because of what? Because of Oracle. So because it's the first market share, they don't want to be risky to change from relational model and object-oriented model. Anyway, so relational model is a database model. So to build such a relational database model, they need to follow this three-schema architecture. What is the three-schema architecture? What is a schema? Schema is description of your database, but it has three different levels of description. One is internal level, another one is conceptual level, top one is external level. First, I model the student data. So student has name and ID, for example. So we can draw the diagram, relational, not relational, just as a diagram as shown before, like this.
Yes.
That is conceptual level schema. Student has name and ID. But when you create the database based on your schema, do you know where the data is stored? No. Who knows it? Who is in charge of such an internal part? Your DBMS program, your Oracle Informatics DB2, SQL Server, your DBMS system will store your data, design the data somewhere in your computer. There might be something, this detailed description, like the name is 8 byte and it starts with whatever. That will be defined in internal level, internal schema. If user need to know everything, it will be very complicated. Do you know how to handle the raw device? Do you know it? Raw device, raw hard disk drive. No. Usually we use a file system software. Then we can create a file. The file system can handle such an internal level. It's the same thing. In the database schema, physically your student data will be stored somewhere in your computer. computer. However, you don't know how to store the data. Instead, the internal level schema can handle such a description. Usually, DBMS program, the Oracle Informatics DB2, they are in charge of such an internal level. Another thing, so you understand conceptual schema and internal schema. The last one is external schema. Can you remember one of the benefits of using database approach? That is multi-view characteristic or multi-transaction characteristic. DBMS is not only for one user, but many users. For example, I have used this room a couple of years on the tablet. It's not easy. So we have student name, ID, and social security number, address, and GPA, and majors. This is a conceptual schema. Somewhere in your hard disk drive will be saved. This is an internal schema. But this data, this student data, is not only for me. HR department would like to access name and ID. Payroll department would like to access name and social security number. Advisor would like to access ID and GPA and major. We need to create the separately. We can do that, but it will be very, very complicated. If we have the HR student, payroll student, advisor student, what if I change my name? You need to update all the database. You need to come by HR department. I change my name, please update my information, then go to the payroll. You cannot guarantee consistency of the data because of duplication, redundant information. This is one thing. Most of the database guys, database concept, database algorithm hate any redundant information. That hurts. Okay, not only waste of your space, but it's a waste of your effort to manage the constraint. Okay, consistency. So instead, we have only one. Then why don't we provide the permission on name and ID to HR? So in terms of HR point of view, student can be viewed as only name and ID. Similarly, payroll office, student, they understand only name and social security number for student. Advisor is the same thing. Sorry, I'm bothering. My voice is usually very high tone. So we can provide a different. How can we implement? We can use view later. This is the standard. You don't have to worry about it even though you do not understand what is the view. It's simply virtual data, virtual table, not real database. But it has the definition. So creating view in one conceptual model can be viewed at many different ways. That is called as external view. We have only one conceptual schema, but it has many different ways. So external level, conceptual level, and internal level are three basic different schema architecture in database model. Most of the commercial DBMS provide such a three schema level architecture. Because of that, we can preserve program data independence as well as a multi-view of the data. For example, conceptual schema and internal schema. student table is here. But because this hard disk drive is full, so we try to move the data into the second one. Do we need to change anything about the conceptual schema? No, we don't have to do that. Only internal schema is changing, and also DBMS software is in charge of that. Even though there are something changes on the internal level, we don't have to change it conceptually. However, if we do not have such a different schema, which means we have the program that would like to access the student file. If we change the format of this one in your program, you need to change everything and recompile. That is the difference. Okay? And that is called the physical data independence. On the other hand, logical data independence means I'd like to add one more information about the cells. Do we need to change the view? No, it's still images. You don't have to change the external view. That is the logical independence in the data. That's the benefit of using database approach. Then the problem is, as you can see here, we need to communicate a lot. So it's called a mapping. We need to map conceptual schema, student to physical location. And also view. Student for payer, student for HR, student for advisor should map with the student conceptual schema. Okay? Also, regarding the model, data model consists of the constraint, rule, common rule, as well as operation. So, regarding to that operation, each and every DBMS model provide the way of accessing the data. That's called the DBMS language. So there are mainly two types of the language. One is data definition language. Another one is data manipulation language. Data definition language is kind of when you build a house, you need a tool. Okay? Hammer and nail and whatever, those are called data definition language. In other words, using that language, you can create the database. The next, on the other hand, data manipulation language is after you build an apartment, for example, you need to find someone who lives in that apartment. You can insert the data, you can modify the data, you can delete the data, you can read the data, retrieve the data. Those can be done by data manipulation language. Okay? So I think most of you guys already know about how to access the data. Select the data from where? Right? SQL. SQL consists of data manipulation language as well as data definition language. We are going to learn both of them after we finish data modeling and database modeling. In addition to them, there are different types of language to support low-level schema, storage level language, storage definition language. But those languages will be for what? DBMS. So as a database user, actually we don't have to worry about it. And view definition language we will learn as a part of SQL. The problem is this is a data manipulation language. In other words, in relational database model, it's called SQL or SQL. That stands for structured query languages. Okay? So I never heard about the SQL. So Professor Lee, one of my comments after the semester is a little bit difficult. But you don't have to worry about too much right now. So we are going to start mainly the next week to learn this stuff. Anyway, that's called the SQL. So you can select something student name from, this is a database language, okay, DBMS. That is totally different from your C program, your program language. What is C#, C, Core, Java, what else? Have you, no, maybe Visual Basic and C#, and many languages. They are totally different, like the oil and water. They cannot be mixed. These languages cannot be mixed, never ever. That's the problem actually. That is the reason database programming is not easy. Why? Somebody said, why is it different? Because this is based on relation. This is actually set. Set is, we consider students as a set, as a one group. But this one is just record by record. In case we have many records, it's called array. But this is just one group of data. So the mechanism to handle the data is totally different. Also, this one is a procedural language. There is a start and end. This one, no, there is no start and end. It's setup. Select from where. That's it. So it's simply no if then else. There is a if then else. You can go to anywhere until end of procedure. So this is called a procedural language. This is non-procedural. They are different. This is called impedance mismatch. Because so if you have an interview for job, if you ask what is the main difference between the SQL database language and other languages, you can say certain thing and why. Those are the difference. Well, why is difficult? You can say because of impedance mismatch. They are two different ancestors, like the water and oil. So we need to consider both of them when we are doing the database program. We will learn later. The database provides many functions and utilities that makes us easy to manage the data, such as backup and recovery or reorganizing. Reorganizing the database is one of the typical job of the database administrator. It's the same as defragment in Windows. Are you doing the defragment when you're doing it? Why? Because it's slow. Your file is not the contiguous data. It's a separate all throughout your computer. Just exactly same in the database. Your student table is not one chunk. It's divided by block, many blocks, all around your system. That makes the degrade of your performance. So reorganizing is drop all the table and regrade, just like a defragment. And report to performance monitor to many tools are provided. We are not going to learn all the tools. Instead, we are going to focus on the data model and database model, then create a database. Even you can use some developing tool like the SDK, like the JBuilder or the Power Builder, or the Visual Basic, or the C# Visual Studio. But as I said, you need to address the problem of the impedance mismatch. So we will discuss probably the after midterm exam. This is a typical component module in DBMS system, which means if you develop the new DBMS, like the Oracle Inform, it's not very difficult, actually. It's much easier than the Unix or the operating system because they are component-based, module by module. So, for example, it has query optimizer to process the SQL data manipulation language, or DDL compiler, the definition language compiler, how to store the data, and the application program will be compiled and performance, something like that. So you can, in advanced class, we implement module by module, like the query optimizer or the log manager. Log manager, what else? We did indexing structure. So by combining, there are several universities who offer to develop the DBMS system. And it's usually the 2-semester long project. This DBMS, this will be the last phrase. What is this?
It's a component.
Similar. Norman? What's this? I explained several times in operating system class. This?
Boxes?
Yes. Rectangular box. What is that?
The F and the box.
Yeah. This box. It's a computer. Okay? This is a computer or a server. Okay? Then, what is this?
Screen.
Screen?
System.
Database?
Database? First, you have the system. Then, what do you need? Operating system, yes. This is the operating system. So, operating system is the software to utilize your hardware. Without operating system, this is a dummy. Okay, no matter how expensive your system is, it's a dummy without operating system. Then, what is this?
CPU.
Yes, the DBMS.
DBMS.
This is a database. Database without operating system, no, nothing. So purchasing DBMS first, I think that's not a good choice. First, you need to think about. So that is the reason when you decide on DBMS, you need to consider hardware as well as operating system. Then find whether Oracle, DB2, they support version, a specific version of their system based on especially the CPU and operating system version. Then, long time ago, this is a computer.